Okay, the first thing we're going to do is I want you to look over here um, at my Desmos settings. Right now I've got two graphs on there. I've got the first graph, f of x equals x squared. That's the black one. I'll turn off the red one so you can really focus on that. Okay, so that's our parent quadratic. And now I'm going to graph the red one. And the red one, you'll notice, is the same as the original. It says it's f of x plus k. So this could just as easily have been written as a new function, and we could put like, hey, g of x is equal to x squared plus k. Okay, so that's what that notation means right there. It's just saying, hey, it's your f of x, which is x squared, plus some k value. And then down here, I can control what that k is, so I can make it x squared plus 1, x squared plus 2. Or I could subtract and make it x squared minus 1, x squared minus 2. You'll see it as I start to move it. So I'm going to turn on the red one, and I'm going to make my k value 0. And you can see they're exactly the same graph. And as I start to change my k, you can see it starts to go up here. I'm going to positive numbers. So here's k is 2. And you can see this graph is going by 2s. Now it's going by 1s. You can see it's just been moved up by 2 units. Okay, so whatever I add to the outside of the function moves it up, or if I subtract something from the outside, it moves it down. So let's go over here and let's look at problem number 1. We'll just see how to graph it. These things are called translations. Okay, a translation is just a rigid change in horizontal or vertical position. Okay, so its size does not change. You're not rotating it. When you do a translation, you're just basically sliding your graph. And so here we've got given the graph f of x. So this is f of x right here. Okay, this weird function. And it says graph g of x, which is f of x plus 4. And we just saw it's just going to slide it up by whatever that number is on the outside. So this whole graph. And when we say slide it up, it slides every single point up. And when you slide every point up visually, it just looks like you've slid this whole figure up 4 units. Okay, so I'm going to do that. I'm just going to take, and what you do is look for key features. Like this is a key feature, and this low point, this little local minimum's a key feature. And so if I move up their m points by 4 units, I'll know just then to connect the line. So here I go, 1, 2, 3, 4. There's my new point right there. Get rid of that little dash line. I'm going to slide up my next point. I'm going to put little dotted lines here. You wouldn't normally show these, but since you're just watching a video and can't see my pen in motion, there's 1, 2, 3, 4. So it moves up to right there. So that new section will all be moved right there. Another key point would be like this peak right here, this local max. It's going to go up by 4 units. So 1, 2, 3, 4. It's now going to be up here at 6. So we'll put a point there at 6. Then it comes back down to right there. And so there is what the new g of x look like. Okay. Let's see here. Next, now notice there's a difference in these two notations. Look where the 4 is. Here's the function with a 4 on the outside. Here's the same function, but now we're putting the 4 on the inside of the function. Let me just show you what that notation would look like. As an example, let's say f of x was something like x squared. If I wanted to move it up, I do this to it, add a 4 on the outside. If I want to move it left or right, I add a 4 on the inside where the x is, okay? And so this is saying, and this is just for x squared. Of course, if this had been like x cubed, then this would be inside the x cubed function. This could be like an absolute value function, and then you'd put the x plus 4 inside the absolute value. Okay, so that's what's going on when they say I'm inside the function. So I'm going to go over here to my Desmos again. I'm going to turn off the outside one. So now k I'm no longer playing with. Instead, I'm going to go down here. I'm going to press this one. So this now is taking the same function f, but now it's putting x And I wrote x minus h inside there, and you'll see why in a second. So I'm going to set my h value to 0. They are exactly the same value. Now when I put a positive number in there, it goes to the right. So my h in that case would just be a 1. And if h is 1, it makes sense that it goes right. Okay, so it'd be like this, f of x minus 1. It just moved right by 1. Notice you got a minus sign inside that function, but it still goes to the right one because the h value is a 1. Let's put an h value of 2 in there, and you can see it goes 2 to the right. Alrighty, let's see what happens when I put in negative numbers, like a negative 1 in there. Negative 1 made it go to the left. You just look up there at the graph, you can see it went 1 left. And so in that case, your h value is negative 1. But think how that would look. F of x minus a. If your h is a negative 1, it would be like x plus 1 inside here. Those two negatives would make a positive. And so when you see this x plus 1, there I am putting that negative 1 in there. And when I put the negative 1 in there, it actually moved it left. Okay, so here's my h again, positive 1, moved it right. Negative 1 moves it left. But the problem is, when it is a negative 1, it looks like x plus 1 that you've plugged in. And so that's what's happening up here. It's x plus 4, and that plus 4 would lead you to believe that it's going to the right. But you have to think in terms of x minus h, like this. And that would force h to be a negative 4, and negative 4 would move left. And I'm going to show you right here on my graph. Here, this is just a quadratic, but there he is. I put h as negative 4, and it moved left, so it'd look like f of x minus a negative 4, which looks like x plus 4. So a lot of our students think of it this way. When it's inside the function, you have to do the opposite of the sign. Okay, so let's see if we can answer or solve this little one right here now. So I know it's going to go left by 4, so I'm just going to move every single point left by 4. And again, I grab a key feature, I go left 4, key feature, left 4, key feature, left 4, etc. So I'll just draw them in here. 1, 2, 3, 4, left 4. So 1, 2, 3, 4, left 4. So there's my first little segment. And I see here it's going to take the peak, and the peak will go left 4, 2, 3, 4. Right there's the peak. And then it takes 2 steps basically to come back down. So there it is, slid left 4. Alright, if you want to try these two, you can. I'll pause for a second, just pause the video. And here I go. Let's see here. I've got my original function. It says subtract 4 from it. This is on the outside. It's just going to take whatever the y value is, because I plug in some x, out comes the f of that number, some y value, and then it drops it 4 units. So here I can see all the y values that came out. Like here the y value is 0. Here's the y value negative 2. It's going to drop those by 4 units. So this will drop down 4. Everything drops down 4. And it looks like this when you get done. Did we do this right? If I do make a mistake, please forgive. Something like that. Shifted down 4 units. And now I'm inside the function on this next one. And inside the function, it does the opposite sign. So this is going to go to the right 4. That's like, hey, h is a 4. And that would mean it would read x minus 4. And so let's go 4 to the right with this guy. And again, I'm just going to see this one's already at negative 3. So 4 right is going to move right to there. And it skips 2 and hits a bottom. So I'm going to skip 2 and hit a bottom right down here. Skips 2, gets back even, goes up to 1, comes back down. Here I'm not necessarily moving everything by 4 steps. I'm just trying to copy the image 4 steps to the right. There we go, and you can see each point. 1, 2, 3, 4, it's moved there. This point, 1, 2, 3, 4, moved there. my peak. 1, 2, 3, 4, move there, and where I return to 0, 1, 2, 3, 4. Exactly 4 steps to the right. Let's see here, we'll do it like this. See if we can keep everything on there. All right, on the outside, what happens if we put something on the outside? So here I've got f of x and I've got a negative. And in class, we've talked about this a little bit. When your lead coefficient is negative, it flips your graph over. So the normal function, this function here, just gives me f of x without the minus sign. And then when I multiply all the y values by a negative sign, it just gives me the opposite sign. So like this is at 3, take it times the negative 1, it now is at negative 3. And so the effect we visually see is it gets flipped over the x-axis here. Okay, this is called reflecting over the x-axis. I'm going to do it with my parabola right here. You can see I'm changing my equations. I'm just going to put a f of x there. And I'm going to make that a slider. So there's a as 1. I'm going to change it so you can see it. Let's make it a prettier color if I can. Or at least a color that stands out, I should say. And it's red. Okay, now watch me as I start to change it. Now I'm not so, we are going to talk about how it's going to get narrower here, okay? Or how it's going to get wider here when I get to these decimals. But what I want you to do is watch as it hits, goes to 0. See how wide it's getting? And at 0 it lays flat. But as soon as a is negative, all of a sudden it's upside down. Okay, now I'm going to make it exactly a negative 1. It's now exactly the same size as the original function, but it's just got a negative 1 in front of it, just like we have right here. And all it did is flip it over. It didn't change its shape or anything. So I'm going to take each of these points and just flip them upside down. This is at 3, so now it goes to negative 3. This is right at the x-axis, so when I flip over the x-axis, it's still on the x-axis. This point's up here at 2, it's going to flip down to negative 2. This point will stay right on the axis of symmetry. If you start on the axis of symmetry, you will not get folded to a new position. You just get folded right on top of yourself, essentially. And there it is, and it's got a little curve, and there I am. I am reflected over x-axis, or the line y equals 0, because that's the equation for the x-axis. Y is always 0 on that guy. It's called a vertical reflection, okay? Upside down. Here's a, let's see here. Ooh, this one's got a bunch of stuff going on. So inside here, I'm going right 2. After I go right 2, this is going to get flipped over vertically over the x-axis. And then lastly, it's going to go up 5. So you got to kind of work these things the way the math would actually work. If you think about f being like x squared, you'd first have to do what's inside the x squared. Then you do your multiplications. And then lastly, you do your additions. Okay, just when you evaluate the function. So let's do them one step at a time. I'll try and map just a single point. So I'm going to take a point here. We'll take him in blue. We'll put him right there. And just watch as I trace his path. So first he's going to go to the right by 2. So there's 1 and 2. Okay, that's the inside of the function. Now he's going to get flipped upside down, but he's already on the x-axis, so he won't move, and then he goes up 5. So there's that first point. Let's do another point, find out where he goes. There he is. He's going to go to the right by 2. He's going to get flipped over the x-axis, so now he's going to be 2 above it. And then he gets slid up by 5 units. 1, 2, 3, 4, 5. He's way up there. Next point of interest is this 1. He's going to go to the right by 2 units. He's going to get flipped over, but he's already on the axis, so he goes nowhere. And then he goes up 5, 2, 3, 4, 5. Yep, lines up right with him. You can see that little V sort of shape forming. See, I've got a peak here now. So let's track where that peak goes to. This will be kind of interesting. He's going to get flipped over, remember? So first he goes 2 to the right. Oops, let's get him moving 2 to the right. See here, I need him tapped. 1, 2 to the right. I flip him over. So now he's one below it, and then I move him up 1, 2, 3, 4, 5. Ah, he is upside down. And my last point, if we track him, here we go. He goes to the right 2. He gets flipped over, so he goes nowhere. And then he goes up 5. 1, 2, 3, 4, 5, right there. I'm going to sketch in this new function, g of x. And there he is, g of x. All right, that's it for graphing functions. Let's turn the page here and see what we've got next. So next we have do these things algebraically. All right, so let's see what it says here. You're given some function. Let g of x be this. Find oh, so they tell us the function. They want us to build g of x, but they say just take f of x and add 4 on. So we're just going to follow the math. G of x is equal f of x, but f of x is this expression. So I'm just going to write that expression instead of f of x. And then it says add on 4, so plus 4. And so g of x, hey, not only would it be shifted up by 4 units, that would be its new equation right there. So this causes it to shift up 4 units or translate up 4, and there would be the new equation. Next one, g of f of x equals f of x plus 4. So here's my function. I have to figure out what the f of x plus 4 is. And remember how this function notation works. If I want the f of 3, for example, I replace each x with a 3, and I'd write, something like, not something like, exactly like 3 squared minus 3 times 3 plus 2. There's how you find the f of 3. I want the f of x plus 4. So I've got to put an x plus 4 in for x. So it looks like this, x plus 4. I got to square it. I have to take 3 times my x plus 4 and then plus 2. So this guy we're going to mathematically work out. Now this is a binomial being squared. Remember, it's x plus 4 times x plus 4. Or x squared plus 8x plus 16. I don't need that first parenthesis, so I'm going to rewrite that just a little bit. X squared plus 8x plus 16. Now I'll distribute my negative 3, giving me negative 3x minus 12, and then I got that plus 2. And now we just collect like terms. So x squared, that's my only x squared. I've got an 8x minus 3x, 8x minus 3x, so 5x's. And 16 minus 12 is 4, and 4 plus 2 is 6. So there's g of x, and that would be, because this is x plus 4 I put in, this would be translated left 4. It didn't ask us for that, but I want to reiterate that's what's happening. This one would be translated up 4. All right, so that's how we do it algebraically, numerically. Let's see here. Given this table, if g of x equals f of x plus 2, find the g of 2. Okay, so this is going to bump the entire graph up by 2 units. So all it's going to do for g of x, it'll just be each of these answers up by 2. So this will now be at 23. This will be at 14. This will be at 20, dot, dot, dot. We want the g of 2. So if we plug in x is 2, it's going to bump my 10 up by 2 units because of this 2. So it'll go up to 12. I might as well fill out that one up too. It'd be at 16. So yeah, g of 2 is 12. Next one, let g of x equal f of x minus 2 plus 1. Find the g of 4. So let's find the g of 4. So that's the f of, I'm going to put 4 in here for my x. So g of 4 is the f of 2 plus 1. Thank goodness they have a table up here, because here is x is 2. This, therefore, is the f of 2, and the f of 2 is 0. So this is a 0 plus 1, or the g of 4 would be 1. And then our last one. This is probably the toughest one on there, example 6. We got a domain here, so I know my domain I'm starting with. There's D. I've got my range over here. The range is 3, 9. Okay, this is for function F. And now we're going to take function G, and they're doing stuff to it. So let's see what they're doing to it. So first inside here, they're going to shift all the X values left 5. X goes left 5. Okay. It does get flipped over, but when you flip it over, it doesn't change X values, it changes your Y's. And then when you raise it up by 2, it doesn't change your X values, it just changes your Y's. So all our X's have to go left. Well, thank goodness, domain is just X values. So on the left end of our domain is -4, but that -4 will be shifted left 5. So our new domain is going to be over at -9. And the 3, which is the high end of the X values, it's going to go left by 5. So I just take 3 minus 5. It's going to go to -2, just like that. So there's our domain. Now for our range, we got to see what's happening. We already said it's going to flip over. And after it flips over, it's going to go up 2. So if we just think about it, we're just looking at Y values. So I'm going to draw, here's my X-axis, here's my Y-axis. And so think about what this 3 does. This 3 starts up at 3 high, and I don't know where he's at in the X, but let's just put him right on the Y-axis and say, I'm at 3. I'm going to flip him over because of the negative. Okay. Yeah, he's going to be shifted left and right, but it's not going to change how high is his Y value. Okay. So I flip him over. Now he's at -3, so he's down here. And then I take him up 2, and he's going to end up right there at -1. So the first value of the range, the 3, is going to be now at -1. And the high value of it, let's see here. High value is way up here at 9. And it's going to get flipped up upside down. So now it's at -9. And then it has to go up 2. So I'm at -8 and -7. So it's going to shift to -7. And now you can see I actually have to flip my range values around. Range on the bottom end of this graph is now going to go from -7 on the high end to -1. So we're going to have to cross this guy out to make sure we write him in proper interval notation. And that is it.